Learning target 7.2b is how do you describe similarity transformations. Okay, so really these are hard to do a lot of examples on. You just kind of have to kind of feel it out. But is there a similarity transformation that maps triangle XYZ, so this triangle, to JKL? And so the first thing you kind of want to think about is how can I move this and make them match up. And so we're just going to kind of play around with these. But on this one, the answer is yes. The answer is yes. The first thing you could do, it looks like it's not a reflection. It looks like it's a rotation. 180 degrees. So let's do that first. If we rotate 180 degrees, the coordinates rule just tells us to flip them. So 2, 1 would become -2, -1 right there. 1, 2, 3, 4, 1 would be -4, 1, which is right here. And 1, 4 would become -1, -4, which I think would be about right there. Okay, so now we've done our rotation 180 degrees. Okay, now it looks like it grew, obviously. So now we have a dilation. And if we look, we got this length and this length should match. So we got 1, 2, 3, 4, and 2 is our scale factor. And so if we take 4 divided by 2, 4 divided by 2, that equals a scale factor of 2. So what we would actually say, it's a dilation times 2. And then if we did that, notice -4, 1 would become -8, 2. And they kind of would just grow out along their ray. So if I draw that out, it kind of makes it hard to see, so I better not do that. I'm not going to do that. But you can kind of see if I do that a little bit, I can use this to show you kind of if we follow our ray out, we're just going 1, 2, 1, 2, kind of stair-stepping. Those lengths match up. You can kind of see that possible. So how would we write this transformation? Well, the first thing was a rotation. The second thing was a dilation. So we would say d of 4, or not 4, sorry, d of 2, because it's a scale factor of 2, and then a rotation 180 degrees around the origin of triangle XYZ. Now, if you look at the next one, it's a little bit tougher, but we can check for similarity. This one definitely looks like it reflects, rotates a little bit. Okay, so we can kind of get creative when you kind of see them this way, but the first thing we need to check then is can we check for similarity by checking the ratios. So if we look, if we take the short side of, we want to go from QRS to TUV. That's what it says. So if we look at the short side, looks like Q to T, S to V. So we check our ratio of 10 to 5. That equals 2. Okay, and then if we go to the next side, we got 24 to 12 equals 2. And 26 to 13 equals 2. So if you notice all of those, that is your scale factor. So we do have a dilation. Okay, so what we would basically say here is kind of the easiest way to describe this is to just kind of line things up. So we're going to rotate, we're going to translate S to V. Then we're going to probably rotate and reflect somehow over VT. and then dilate by 2 from point V. Okay, so that's kind of some of the things that we would do. So like if we translate, so I'll kind of just draw it real quick just so you can see it. If we take this figure, and I'm going to use my tools to kind of help us here. Okay, if we take this figure and I go like this, if I translate it right here, okay, and then I rotate it, if it'll let me rotate. See, so we rotated, maybe we should have rotated first. Okay, obviously now you can see if I reflect, but then I can also grow it. Whoop, too much. I think we grew too much, didn't we? But then I can reflect across and it matches up. Isn't that kind of fun? So you can kind of see how we did that there. But that is how you're going to do 7.2b. You're going to try some Delta Math to just let you play around with it a little bit.